Okay, here we find ourselves in section 5.3. So we've been introduced, I apologize, to the identities, and we're going to give you some more identities. These are the sum and difference formulas. So if I were to open up a calculus textbook, like I mentioned before, the back cover would have all some trig information on it, and included in that not only is the special angles and things that you should have memorized, but also these sums and differences for cosine and sine. And the reason why is they're used a lot. And so what we would like to do is have you well familiar with them. I'll try to give you a way to memorize it. You definitely want to have it memorized. Now, you'll have notes when you come to the exam, but please don't expect that in future classes. In fact, it's just going to be one small part of a larger problem, so don't sell yourself short as you're able to take notes to the exam. So here they ask a question: does cosine A minus B equal cosine A minus cosine B? Why or why not? Well, the best way to show what the answer is to look at a counterexample, because the unfortunate reality is no, it's not that simple. And so what if we looked at something like cosine of 90 degrees minus 30 degrees? Well, is that really equal to the cosine of 90 minus the cosine of 30? And let's take a look. So the cosine of 90 minus 30 is the cosine of 60 degrees, and you know the cosine of 60 degrees by memorization is 1/2. We need you to have that just like that. If you're looking at a calculator to find that, you are on dangerous ground for moving forward from this class. Cosine of 90 degrees. We know what that is. Cosine corresponds to x at 90 degrees. Your x coordinate is 0. Minus cosine of 30 degrees. We know that that's root 3 over 2. And they're not the same. Now, we may have been able to argue that another way, but a counterexample is just as good. And so it's asking for us to derive the formula for cosine A minus B, this sum identity for cosine. And I don't want to recreate that because it's already in the book. So your book has it done really nicely. This is the sum and difference for cosine. Cosine A plus B is equal to cosine A cosine B minus sine A sine B. And cosine A minus B is cosine A cosine B plus sine A sine B. That's what's derived in your book. And so we're going to just get practice using that in this video. If I encourage you to look at the derivation of them, but I think it's well explained. I looked at it and I thought that they did a really good detailed job. But if you have any questions, I could recreate it or walk you through it on Zoom as needed. So the way that I'm suggesting to memorize this, now there's going to be two sets, one for cosine, one for sine. You haven't seen the one for sine yet. So what I want you to know is this. When you look at this, they're both the same. Cosine, cosine, sine, sine. So the same. Cosine, cosine, sine, sine. So because they're the same, what's going to be the difference is going to be the sign in the middle. Okay, so we'll have the sign in the middle be different. So I walk into I'm going to just say, I was going to say walk into the exam, and I stopped myself because you're going to say, well, I'm going to walk into the exam with notes. I'm going to walk into calculus knowing that, hey, if I'm going to do the cosine of A plus B, that's the cosine, cosine, sine, sine one. And if it's cosine, cosine, sine, sine, it's the opposite sign in the middle. That's what's going to get things to work out. And we have these cofunction identities as well. So they're asking us to, I don't know if you remember these cofunction identities, but we had them back in chapter 1 or 2, I think chapter 2. And they're in degrees at that point, but 90 degrees minus theta. There was a question on your exam to use the cofunction relationships in order to get the value for theta. And so you did that just like you did in the homework. And so these are the cofunction relationships. So they want us to derive one. So let me show you what they'd like out of that. Use a cosine identity to derive a function. All right, let's look at the very first one. Cosine of pi over 2 minus theta. Okay, we're wanting to show that that's equal to sine theta. So we're going to look at this very first one right here. Okay, right up over here if you didn't see where my pen was going. So, what does this say? Let's see if we can remember it. It's cosine of the first angle times cosine of the second angle minus, oh, actually opposite sign, right? Plus sine of the first angle times sine of the second angle. Whoops, second angle is theta. Well, what's cosine of pi over 2? Well, it's 0 times cosine theta plus sine of pi over 2 is 1. Oh, yeah, plus 1 sine theta. And 0 times cosine theta is cosine theta. 1 times sine theta is sine theta. Did we show the identity? We certainly did, right? And you would use something very similar to that. So we're just wanting to use the relationship to show that it establishes these cofunction identities just fine. So here's what a normal problem is going to look like. Now, this is number 12. Now, you are here in a situation where you're able to use your calculator. These questions are written so that you're not supposed to use a calculator. So the ones in the book, they want you to find the exact value. If you give me a decimal approximation, I won't count it, right? It's not right. You have to give the exact value that's there with the square roots and everything. And so I'll even ask you to show I'll say use the formula, show your steps, don't use a calculator. So I'm going to tell you some advice, right? Because I'm a human, and so you can get stagnant type of results from a book. But when you have a pi over 12 angle, we need to build it, right? Or an over 12 angle. I shouldn't just say pi over 12. So let's talk for a minute. We have to work with angles that we know. We know about pi over 4. Let me see something for a minute. Come back here. I'm going to just make this a little bit thinner. And then come in here, erase that. Drive me nuts a little bit. So we have pi over 4. We have pi over 3. We have pi over 6. I'm sorry, I didn't do them in numerical order. And those are the ones that we're working with. Get them to be over 12. And let's see which two can help us get pi over 12. Well, this is 3 pi over 12 with simple fraction work, 4 pi over 12, and 2 pi over 12. Do you see a way that we could get simply pi over 12 by either adding or subtracting these? Because if we can add or subtract those, let's just come right back up here, we'll know exactly what to do. Well, take a look at these two. What happens if I take 4 pi over 12 and subtract away 3 pi over 12? Well, then I get pi over 12. So really, the cosine of pi over 12 is equal to the cosine of pi over 3 minus pi over 4. That's how we're going to do it. So that's my suggestion to you, is to build them in such a way that that they're related to angles that you know. That should be the hardest part. Now let's see if we remember. Okay, it's cosine, so that's the cosine, cosine, sine, sine one. So this is going to be cosine of the first angle, cosine of the second angle, and then opposite sign in the middle, sine of the first angle, sine of the second angle. Now it should be this fast. Cosine of pi over 3, 1/2. Cosine of pi over 2, root 2 over 2. Sine of pi over 3, root 3 over 2. Sine of pi over 4, root 2 over 2. Root 2 over 4 plus root 6 over 4. And they'll put it as one solid fraction as root 2 plus root 6, all divided by 4. Okay, done. That would be reflected in the back of the book. Root 2 plus root 6, all divided by 4. And so you'll get reinforcement of that. They'll have us look the other way. We should look at this and be like, oh, this is a cosine of two angles being added. So this is the cosine of 7 pi over 9 plus 2 pi over 9. That's the setup for it. Cosine, cosine, sine, sine. Since it's a minus sign in the middle, it must have been an addition. So this is cosine of 7 plus 2 is 9 pi over 9, which is the cosine of pi, which from our first test, one of the first sections in the book, we know that the cosine of pi, or the cosine of 180, is -1, and we're finished. So if it's not that quick, if you're having to go to a calculator, please study those angle identities more, especially before going to the next course. So let's take a look at this. Find one angle that satisfies the equation cosine theta equals sine of theta over 4 plus 3 degrees. And so, well, what we need is a cofunction relationship. So maybe you don't remember, but the cofunction for cosine, I hope you remember, is sine. And we remember from our first exposure to it, it was in degrees, so we're going to have it in degrees here as well because of the 3 degrees. So I'm trading out cosine theta to what it is from its cofunction relationship that we didn't learn just now, but we learned for the first exam. Let's go up though and just show you where we're getting it from. We're trading out the cosine of theta for the sine of pi over 2 minus theta. You know pi over 2 is 90. And so why am I doing that? So that we can get to this stage, because sine is a one-to-one type of function. If the sine is, well, actually they're saying find one angle, so we're going to assume that the angle is acute. That's what they did back in the past. They said, hey, find the acute angle that works, and that's what we're going to find here, is the acute angle that works. So we just set it up. 90 degrees minus theta has to be equal to theta over 4 plus 3. So we're going to subtract 3 to both sides and get 87 degrees. Add theta to both sides. I'll go slow here in case there's an issue with your fraction work. We really hope not. We're hoping that 87 degrees that many of you already wrote, hey, this is 5 theta over 4. If you don't know that 1 theta plus theta over 4 is 5 fourths theta, we got some problems. If you don't know that theta could be written as 4 theta over 4 and go from there, we got some problems. You know now what you do. You multiply both sides by the reciprocal of 4/5. And using a calculator, 87 times 4 divided by 5 is 69.6 degrees. Now they may list it as a fraction, but it did work out to be exactly 69.6 degrees, so whatever you want. But that's what the answer that they would reflect in the back, or its fractional equivalent that's there. Okay. See how much, yeah. So we do have a few more examples that are here. Let's look at this one more, and then we'll probably split it. Write the expression as a function of theta. Now notice it's not minus theta, but cosine of 90 degrees plus theta. Easy. Cosine of the first angle times cosine of the second angle minus sine of the first angle, sine of the second angle. Cosine of 90 degrees, cosine corresponds to x, so that's going to be a 0. And so we'll get a nice 0 out of that times cosine theta. I'll just do it one step at a time. Sine of 90 degrees is 1 sine theta. And so I got 0 minus sine theta, which is minus sine theta. And that is the function expressed as a, well, the expression written as a function of theta. So we have 3 more problems that they would like us to do. Here, I don't know whether to split it or not. Actually, let's not. Let's just work these 3 problems out. This next one, why don't I just do one of them? The other one would be almost the exact same, and you'll have all the numbers doing it. Find cosine s plus t. And they're giving us cosine s and sine t. So let's talk about that for a minute. We need to figure out some things. We need to do some early chapter 2 work, stuff that you did on your exam, and put that together with here. So what we do know is if I'm going to do cosine s plus t, let's start with what they want us to do. Then I'm going to need to know cosine s, cosine t, and then subtract from that sine s, sine t. And the problem right now is I only know cosine s, and I only know, actually, I'll keep the same highlighter, sine t. I need to figure out these other ones. So I got to draw myself a picture. We're back into the first test. We never lose that skill set. So what do we know about S and T? Well, they don't have to be, but they're both in quadrant 4. So this is now side work. So I'm just going to label it as side work since I can't really go off to the side. So let me just draw a picture of S. So here's S in the 4th quadrant. Right, is this 4th quadrant angle. I could draw it like that, but we really want this reference angle. The cosine of that reference angle is root 2 over 4. So what do we know? We know we want to find this y. We know that y is negative. No problem. We know 4 squared is equal to root 2 squared plus the y squared. So we know 16 is equal to 2 plus y squared. We know y squared then is equal to 14. So y is equal to negative square root of 14. Remember, it's plus or minus unless you know something. We know we're in the 4th quadrant, so we know it's negative. So now we know that y is negative 14. So what do we know? We know the sine of s, which we didn't know before. We knew the cosine of s is negative root 14 over 4. Does the negative make sense? Absolutely. We're in quadrant 4. The sign would be negative in quadrant 4. Still side work. We got to figure out angle T. Angle T is also a 4th quadrant angle. Its sine is negative root 5 to 6. Okay, so we need to figure out this x, and we know that x is positive because we need to know the cosine, so we need that adjacent side. No problem. X squared plus negative root 5 squared needs to be equal to 6 squared. So x squared plus 5 better be equal to 36. So x squared is equal to 31. So x is equal to the positive square root of 31. And the sine of t is, we knew the sine of t. Just going to write the same thing we already knew. The cosine of t is equal to root 31 all over 6. And now you can see why they did that so many times before. We're just going to need it from time to time. We're going to have partial information, but with partial information we can get everything. Cosine being positive, does that make sense? Absolutely. All students take calculus. In the 4th quadrant, the cosine would be positive. So we just plug in what we knew and what we found out. So now we have root 2 over 4, and cosine of t, we just figured out, was root 31 over 6, minus sine of s, I'll put it in parentheses since it's negative, and sine is negative root 14 over 4, sine of s, and sine of t was given me negative root 5 over 6. Alright, so that I don't get crammed in here, I'm going to erase my side work, because you can always back up the video and look at that side work. Okay, get rid of all that side work, sorry about all the little marks. Need to go away. Okay, so we'll get rid of our side work in here, and we'll go finish the problem. Now the rest is arithmetic. So remember, in the beginning it was chapter 2, knowing one of the trig relationships in a quadrant. Could I get another trig relationship? Yes. Can I use this section of the days thing? Do I know what cosine of s plus t is? Sure, by memorization, right? You're going to just look at it and write it down potentially right away, but I would highly suggest memorizing. Now we're simple arithmetic, right? Probably pre-algebra or algebra 1 arithmetic, but nonetheless arithmetic. Square root of 62 all over 24 minus a negative times a negative is a positive, root, and then 14 times 5 is 70 all over the same 24. It's not, it's very unusual not to have that exact same common denominator. We are done. The answer is root 62 minus root 70 all over 24. That is good work, right? That's the math that we need later on. We don't care what the number is really. We care that we can get to the number and rationally think through it. Determine if this statement is true or false. Cosine of negative 24 is equal to 16 minus 40. It is false, and here's why we know it's false. Because if it was true, then cosine of negative 24 degrees, which is equal to the cosine of 16 degrees minus 40 degrees. Notice 16 minus 40 weren't arbitrarily picked. What's 16 minus 40? Negative 24. But we already know that this is absolutely not equal to the cosine of 16 degrees minus the cosine of 40 degrees. What it is equal to is cosine of 16, cosine of 40 minus sine of 16 times sine of 40. Right, or plus. I said minus, but it should be plus. It's not equal to this, so it's absolutely false. Okay, that's like number 58 in here. And then what's awesome is throughout all of these sections, they keep the identities alive. And so you're going to be proving identities that have a relationship back to this section, right? But really rely on all the previous sections. So they're going to build a better you as you go to each one of these sections. You're not going to lose your 5-2 skills. You're going to be using them. So here where we verify the identity, let's work from the crazy side right here. And you think, well, what to do? Well, we got a huge problem because of that 2x. We need cosine to just be x, not 2x. Well, we know how to do that. Let's remind ourselves what cosine 2x is. It is just simply cosine of x plus x. Nobody needs to teach you a double angle formula. In fact, this is how you're going to prove it. And there's actually more than one double angle formula for cosine. But this will generate one. Cosine x minus sine x sine x. That's what that's equal to. Cosine, opposite sign in the middle, sine. And so what is that? That's cosine squared x minus sine squared x. That's the baby. I shouldn't say the baby. That's the parent, right? That's the first one that we stumble across. So there will be a section in which we do double angles, and this is exactly how we're going to prove it, right? We won't even need to do it then. So let's put that in. Remember, this is a replacement for cosine 2x, which is right here. Now, why did we do that? Let's make sure you understand. Well, somebody will sit back. I don't know why you knew how to do that, Jensen. It's a trick. It's not a trick. Take a look at what you want in the end. What you want is cosine operating on x, not 2x. You got to get rid of that 2x thing. So it's not crazy. It's not seeing something weird. It is just paying attention to what you have and what you want in the end. I don't want 2x's. I just want x's. Now I got them. So now I have 1 plus, and just to highlight, I'll come in here in blue. We're replacing this with cosine squared x minus sine squared x. And then we're going back to what we had, minus cosine squared x. That's that left-hand side. Take a look at what can cancel. Cosine squared x minus cosine squared x. Well, that's 1 minus sine squared x. Think about your Pythagorean identity, namely that cosine squared x plus sine squared x is equal to 1. Always think about that when you have a sine squared or a cosine squared. So what's 1 minus sine squared x? I know you see it. Cosine squared x. And you're finished. You showed that the left-hand side can just be condensed down to cosine squared x. Pretty awesome. So that is the highlights from 5.3. It really is just getting familiar with this formula of the sums and differences of sine and cosine and using them. And then we'll get extra practice with this in the 5.4 section as well, as we do it for sine and also for tangent. They just put them all together there because they feel like, hey, you got the picture here. So, all right. I'll see you in 5.4.